postdoc, many of the government injected the grants has had a very fruitful results. But then the COSPA program in Taiwan, and not only stop here, as you already see, Paul mentioned the buildings are lined up here, and we have this next speaker who was able to inject some other ways of developing cosmology program. We have a new building next door. So this is a new addition of to our cosmology program. So the speaker will be Pisin Chen from COSPA to the COSPA. Thank you.
It's such a tremendous. Excuse me. I'm just coming out of a flu since a few days ago. Sorry for my voice here. So it is a tremendous honor, not just honor, tremendous honor to be asked to give this presentation in our memory of Pauchy Hwang, who has made his influence in so many different ways. And here I have the honor to touch upon yet another one of his contributions. So as a way to memorize his great achievements and contributions, as you can already smell by looking at the acronyms of COSPA and Le COSPA, you know, you can even smell the deep connections, and which is true. So as many of you in this room know, Pauchy initiated this COSPA Center, as Xiaogang at the beginning mentioned, in the year 2000, which was a time only a year after the discovery of the accelerating expansion of the universe, and many other great remarkable discoveries in cosmology and particle astrophysics. And so he had the foresight to initiate such a program, pilot program, and indeed succeeded in hosting that for 8 years, from the year 2000 to 2008. And concurrently, although not coordinated, I initiated a Chen Institute for Particle Astrophysics and Cosmology at Stanford, established also in the year 2000. I had the thought and succeeded in helping to persuade my younger brother, Pi-Hong Chen, who is also an alumnus of NTU, who's in the middle, to make the initial donation. And this is the former Stanford University president, John Hennessy. This was the then SLAC director, Jonathan Dorfin. Now, having this consensus, across the Pacific, we decided to collaborate. So, I invited Pauchy to join an experiment that Pierre Sokolsky of Utah, the PIA of the high-res experiment, and myself to push to make a laboratory measurement of the photon yield per cosmic ray shower particles by the acronym FLASH. The physical motivation was that at the time there was a discrepancy with regard to the very high energy tail end of the cosmic ray spectrum, around 10 to the 18, 10 to the 19 eV, between the Japan-based AGASA experiment, which utilizes the ground array detectors, and the fluorescence-based detection by high-res. So we set out to do a laboratory experiment, control experiment, to resolve that discrepancy. And Pauchy was involved, as well as the NTU Le COSPA, And so this was called the SLAC E165 flash experiment. Stands for fluorescence in air by showers. This experiment lasted for 8 years. After I joined NTU in 2007, it still continued quite successfully. This was a photo taken in what's called the FFTB, an extension to the famous 3 kilometers like LINAC. In the picture, there were 3 students of Pauchy and Woei-Yann. This is from National Chiao University. These 2 from NTU, Chen and Chen. This was myself. So we were in the middle of preparing the experiment. Now, was it Haiyang or was it Renjie? Just now mentioned about Pauchy's practicing Chinese calligraphy. Not sure if you have seen Pauchy's handwriting. It's so beautiful. Oh, the resolution is not as good. Perhaps maybe the first few lines. This is a funny, sorry, I mean, in this solemn occasion, this is a kind of funny thing. This was his handwriting pasted on a refrigerator inside an apartment that he rented for the students to come over to do the experiment, the flash experiment. This apartment was just right outside, across the street from SLAC. Those who have visited, the Sand Hill Road, it's on the other side. And the trigger of this was, after an experimental run, the students went back to NTU here. And later, maybe during winter break or sometime, he took one of his sons, was that you? Your brother? Okay, so they went, and they want to spend a few days there. Of course, every time when he came, we met and so on. And he was totally mad. He was just, blow up. Your brother must remember. Because the students, and as everybody here in the room knows, our students and our chairman knows well, they never care the tidiness of their research space. Go every floor, you will see. Just even a fish tank can be there for several years, and it's all in green, and it's still in that same room on our 8th floor. So that's so that apartment was just in a total mess. So he put down this handwritten, rules to the students to keep, to be responsible to keep the apartment tidy. And if they do not follow, they should move out to, find their own place somewhere. So this was his handwriting. Here's a photo taken at some point. I believe it was Feng Chang's PhD. How should I say, ceremony, and afterward we had a dinner together. This was Woei-Yann also in the audience. Yeah. So those were a very memorable time. And following suit, I also grabbed one of the many papers we published. And Woei-Yann, of course, was also one of the active collaborators from Taiwan. And this was a representative one where we did resolve this discrepancy between Agasa and high res. And this is being one of the records, and Pauchy's names here, myself, and many other. And please note the institutions put down as a footnote at the bottom, COSPA, Taipei, ROC. So this was the legacy, and that eventually, one more. So this COSPA lasted for 8 years, and many of us remember that while he was still healthy, and this, by the way, I forgot to mention, when I was an undergrad student at NTU Physics, he was 1 year senior to me. We saw each other often in the corridors of that old building in Yelin-Dada. But we didn't quite have close interactions, just say hi and so on. So we knew each other. But over the following several decades, we were just, had our different ways. So my close interactions with Pauchy started the year 2000. It's kind of a renormalized. And that was the time he, in fact, I was a few years earlier, how should I say, switched over and migrated into cosmology and particle astrophysics, and there we come fluent. Now, so this, according to his quote-unquote autobiography, where he described himself with 3 lives. So this was more in the transition from his second life into his third life. Now, talking about that, I must mention that the trigger of that third life actually has to do with our collaboration of this flash experiment in the year 2004. In March, he had a visit to SLAC, to continue on with our flash collaboration. But it was clear at that time, although I was, I was not familiar with at that time the Taiwan situation, but all I saw was that he continued to make phone calls back to Taipei, because that was a time when his COSPA Center was facing the decision for the second cycle of support from 2004 to 2008. And I could tell that he spent quite a lot of energy, and he was quite tense about that. And indeed, very unfortunately, the morning after he returned to Taipei from Stanford, and he suffered the stroke. And that was the beginning of his third life. And so although I didn't, of course, come together back to Taipei, but it's kind of so close to my memory, because we saw each other just the night before. Now, another of Pauchy's legacy of the COSPA was this COSPA is this COSPA conference series that he launched and organized almost every year until until 2004, when he suffered the stroke. But after 3 years of rehabilitation, he managed to restart again. I think that the first one was 2008, and he continued for one more time, 2010 or so. By then, the colleagues within the Asia Pacific region decide to circle around this conference series among different regions in Asia Pacific. And this is now alive and well. Just a few weeks ago, both Xiaogang and I attended the COSPA 2018, organized by Yangzhou's Center for Cosmology and Gravitation. And too bad that this photo that I have did not have the other side. This is also in memory of Pauchy. Especially, there was one afternoon session. And again, I think your brother gave us a brief speech at the beginning. Yeah. Now, it's as an honor of Pauchy, as well as his earlier desire, the COSPA 2019 of next year will come back to Taipei. In addition, at the COSPA Asia Pacific Organization for Cosmology and Particle Astrophysics Council meeting in Yangzhou, I proposed, and this is in honor of Pauchy's original desire, to host this Asia Pacific Organization of Cosmology and Particle, AP COSPA, in Taipei, now that we have some extra space in this Leon Cosmology Hall. This is still under discussion, and there are different ideas and so on. But I'd like to mention that this was truly in honor of Pauchy's desire. We had talked about that a few years ago, but unfortunately, I didn't manage to discuss with him again before he passed away. But this was clearly in our minds. In doing so, then we can register to Taiwan's government as a non-profit organization. So now a few words about the COSPA. The establishment of this also has to do with Pauchy. Now, in 2005, when it was clear that the government support for COSPA has been largely reduced to some minimal amount, he and I decided, and I was very enthusiastic in helping out, to talk to the newly elected NTU president, Chen, to persuade him an extra support to continue on this legacy, which is a very important, exciting field where the world's leading universities are competing for the leadership. And that was actually the beginning of my joining and returning to NTU. And because right at that discussion, our Dean of College of Science, Pauchy Hwang, asked if I would like to come back. Now, so the rest was history. We managed to find Mr. Chen Liang Zizhen, who was a distinguished NTU alumnus, to make the donation, and therefore we add his first last name as the name of the new center, but COSPA, the name COSPA remains. So this was a photo taken in November 13, 2007, when Liang and Chen, university president, signed the donation agreement. During a conference that Pauchy organized, and you can see Pauchy and myself. Xiongyi, where are you? Yeah, Xiongyi is here. He was then the department chair. I think I remember it right. Now, in 5 years, in June 2012, Mr. Liang decided to donate another 19 million to turn the COSPA into a permanent operation. Pauchy is in the small in the audience, but I think he was not. Let me see. 2012, yeah, but he was not standing up, but he's there. Now, just now, Paul mentioned about this building that connects our Guan and Taiwan Shuxue Guan. This is the legacy of C.C. Liang. Now, just like to mention to you that this building, designed by Chris Yao Renxi, was recently got into the finalist of this famous World Architectural Festival Award, and it's supposed to be announced. The final prize award should be announced as of yesterday, but just now I googled, I didn't find information. Maybe we lost, but to be just like World Cup, 世界杯足球赛, to be among the 16 in the final list was already a great honor. And I'm happy that our university and as well as Taiwan can have some building that was in such a very prestigious architectural competition. A snapshot of the inside, if you have not been inside yet. There are 4 giants of cosmology standing there. And here is Galileo and Newton. The other 2 are Einstein and Zhang. You're welcome to take a visit. This is the lobby on the 7th floor, and this is the a snapshot of the inauguration ceremony taken a year ago in November 28th last year. Now, Pauchy and Jane were there, and let me zoom in. So I was very happy to see that both of them laughing so hard This was a happy moment. So I feel tremendously honored and pleased that this Leon Center hopefully helps to carry on the banner that Pauchy has created. And currently, the COSPA Center has 3 major experimental research directions. And so if you allow me, let me make a quick introduction of what's being done. The one direction is in the search of ultra-high energy cosmic neutrinos. This is a direct legacy from this flash experiment that I mentioned to you that Pauchy and I collaborated. Now, cosmic neutrinos occupies about 0.5% of the total composition, total substance of the universe, but this is also the least understood among all elementary particles. And so we wish that to make better understandings of that. And there were several projects under this overall direction that COSPA has been involved. One is called ANITA, and since the year 2006, before I came back, it has already managed to have 4 missions up to this year, and each time there was very exciting discoveries. This was taken during before the launch of the 3rd mission. The ANITA detector is getting heavier and heavier each time, just by adding more rings of detectors, and in order to increase the sensitivity. But of course, this is nice foreground. This was taken by Liu Zhongzhe, again one of the students of Guilin. And now, one of the discoveries was accidentally, because we didn't expect that before. We wanted to look for the highest energy neutrinos, but the first thing discovered was the highest energy cosmic rays. And what happened was that the cosmic rays, made mostly of protons and some ions, will quickly turn into showers upon entering the atmosphere. Now, we didn't quite expect to have a radio wave signal that to hit the detector, but thanks to the geomagnetic field, which is essentially all vertical around the South Pole, triggers synchrotron radiations of the showered electron-positron pairs, which fans out, but then it's clearly polarized from positron to electron, and that's mostly parallel to the surface of the ice. And so in addition to the direct hits, there can be also perfect total reflection signals. And so our NTU team, in particular Jiunam, had made this first discovery, and of 16 events within 30 days of flight. And that efficiency is actually comparable and even better than the world's most sensitive cosmic ray detector by the name Pierre Auger in Argentina, which covers 6,000 square kilometers. But this is just a tiny detector, so you can see how effective it is. Now, though powerful, ANITA can run only for a month or so because of the need to use solar power. And well, we all know that at the pole there's only half-year daylight. So in 2009, after I joined NTU, I initiated this new idea called AURA to turn this very successful detection method back to ground. And at the pole, this is the famous ice cube, which is exactly 1 kilometer in size. And this is the skyway, the runway. By the way, this runway is unlike any of the airports you are familiar with. There's no guiding light, there's no directions, just try your luck. And so the ambition is to eventually develop a 200 square kilometer array to look for ultra energy cosmic neutrinos and cosmic rays. So far, we have deployed 2005, and most of the hardware, the downhole system, was built by our NTU team. And since we have the technology, and 2011, I had the chance of visiting the pole. This was Taiwan's first major experiment at South Pole, which is still going. Now, since we control the technology, we so NTU alone, Taiwan team, has developed a new program in Taiwan. This is on the east coast of Taiwan in Hualien, Hepingxiang, between Yilan and Taiwan, Hualien on the border, overlooking to the west, to the east, to the east of the Pacific, where the geomagnetic field now is turning north to south, and we look at the cosmic rays coming in from the side, similar to what I had just described to you, as well as tau neutrinos, Earth-skimming tau neutrinos, which happen to decay into tau, and tau penetrate out from the ocean, can develop into shower, and we can measure that. And this program is also going on strong. The latest was we have deployed Target 3 as late as July, a few months ago. And in this new academic year, we're going to deploy 2 more stations. And together it will be 5 detector arrays. And currently we are busy analyzing data. This, by the way, puts Taiwan for the first time on the world map of ultra energy cosmic rays and neutrino detection. The second direction that we are pursuing right now is about inflation, in particular the so-called the B mode of the CMB and isotropy, CMB spectrum. Now, as most of us know, during inflation, quantum fluctuations trigger density fluctuations. That's what we often see, the blue and red, kind of patterns. Those are what's called scalar perturbation, because density or temperature fluctuations are just a number, so they're scalars. But during the same time, and again, quantum gravitational effect, this space-time web should in principle also fluctuate, and that's called the tensor mode. Now, the rate by now experiments all support the idea of inflation, but there are many inflation models or theories. Which one is exactly right? The right one relies heavily on what's called the R ratio, the tensor to scalar mode ratio, which can be determined by measuring the so-called B mode CMB polarizations. And what's good about that? It's not just that this is the earliest possible gravitational wave, but that also helps us to push our understanding of the history of the universe from the recombination time, where the CMB photons are released, all the way back to the 10 to the minus 35 seconds of the inflation time, simply because gravitational waves are not affected by all those intervening interactions, and they put their marks or footprints onto the CMB spectrum. Now, so that's arguably the final gem or last very important parameters to measure for inflation. And that can also help us to understand what causes the inflation, what's the origin of it. And as many of us remember, a few years ago, the BICEP2 collaboration announced their discovery of this BMO, but unfortunately, later data show that the contributions were most from the foreground dust, the foreground effects within our galaxy, contributed by dust. So many groups in the world continue to compete in searching, finally, nail down this R ratio, this B mode, which is possibly as small as 0.01. And so it's hard. Okay. Now, so we now have a collaboration amongst Beijing's IHAB, the U.S. in the U.S. National Institute for Science and Technology, NTU, Stanford, Arizona. The sky view coverage was this piece, and this piece. This helps to provide a very very important complementarity to the existing measurements that are mostly in the southern hemisphere. Within a year's time, by the way, the elevation of this observatory is in the Ali region, the westernmost part of Tibet. And this was the photo taken July of last year. And by July of this year, the observatory civil construction is already done. The goal is to build a full-blown observatory at even higher elevation a little later. The third direction is trying to resolve experimentally what's called the information loss paradox. And this is well known, and to this room, it doesn't need me to review. So Hawking's seminal discovery of black hole evaporation seems to suggest that the information initially contained in a black hole, upon the evaporation, will eventually turn into heat, which provides very limited information. It's and so where has the information gone? This is a serious matter because conservation of probability or unitarity is a fundamental tenet of quantum mechanics and quantum field theory. Now, so seemingly there is a inconsistency between quantum field theory and general relativity, the two most fundamental science revolutions in the last century. So many people set out to debate on this, but essentially all theoretical in the past 40 years. And the reason is very simple, because an astrophysical black hole, let's say a solar mass, I don't mean exactly one solar mass, which cannot become a black hole, takes 10 to the 67 years to evaporate entirely. Yet this information loss paradox relies critically on the ending of the evaporation. So it is, and yet our universe is only 10 to the 10 years, so it's hopeless unless you can live forever to get this measurement done. And so many people set out to introduce analog black holes so as to resolve this issue in the laboratory setting. So last year, Juramuru and I published an idea called flying plasma mirror as an analog black holes. Simply put, it's like invoking the equivalence principle. So this a piece of flying mirror can mimic the physics of a black hole Hawking evaporation. This is well known if you go to any of the standard textbooks of quantum field theory in curved space-time. The only contribution is that we think of how to realize this. And also, by the way, some of you may know that my co-author Juramuru received this year's Nobel Prize. And so actually I was invited to go to Stockholm in a few days. Not that I'm receiving Nobel Prize, but I'm going there just to watch. I think that should be fun. Now, so last year in April, after we published the paper, I called a meeting at NTU to establish a new collaboration by the acronym ANNABEL to actually carry out such an experiment. And Juramuru came. So we took a photo. I showed him the yet to be completed, finished new building. This was on the 7th floor. If you can, steer into there's our 醉月谷 is in the background. So this is quite nice. Well, this is too technical. So I have some conceptual design of this experiment. All right. And so currently it's a multinational collaboration. There are several stages of development, and let me not bother you with that. So, let me at least say that I wish that at least the first stage be done in Taiwan. 10 years ago, our NCU laser facility led or created by Wang Zhiping was among the top front laser facilities in the world, 100 terawatt. But 10 years after, by now, we are falling behind. I strongly urge our most to put in more, because everywhere else, 1 petawatt is commonplace now, let alone 10 petawatt. So the final stage of this experiment, unfortunately, cannot be carried out here. We may have to go to Apollon in France and somewhere else. But anyways, this is pushing forward in earnest. So this is my last page. I'd like to mention that Pauchy and I last met the day before he passed away, on May 4th, in front of Fuzhou. And I was very happy to see him in the wheelchair, and we shake hands and so on. I regretted that I didn't have the thought of having a zipai or something. So that photo didn't exist. Now, but we went there to support the students, to demand for the government's decision to appoint Guan Zhongming as our university president. And so let me finish by saying, rest in peace, Pauchy. We will carry on your legacy. Thank you.
Thank you, Pisin. It's a question to Pisin. Well, I think we can also have questions to all the 4 speakers this afternoon. Now we have a few minutes before we go to the coffee break. Any urgent, interesting questions I want to ask? Well, I think all these speakers, as I expressed everything well enough. No losing hand for questions. So then let's just say, well, for this, as Pisin says, Rick Pouch, we will carry on your legacy in many different ways from the department, from researching in the high energy physics, cosmology. Okay, so let's thank all the speakers for this session.